Hi, my name is Emily Reeder, and I'll be your instructor for this course. In this class, we will learn to forecast the financial value of a project using the discounted cash flow method of valuations. While our focus will be on the theory, we will see many examples of exploring and building financial models using the R programming language and the tidyverse. Valuations estimate the economic value of a company choosing to pursue a new investment opportunity today, like starting a new project. The methods we'll discuss are used in venture capital, private equity, and other industries to value entire companies, but our focus is valuing projects within a company, like buying machinery, launching a new product, or even implementing an algorithm. Forecasting a project's profitability can help you decide whether or not you might want to do it. Then, you can prioritize the ones that are most profitable or pick between competing alternatives. Valuations contribute a financial lens to the complex process of business decision-making, alongside many other quantitative and qualitative considerations like reputation, mission, and long-term strategy. Valuations can be done many different ways, but in this course, we will focus on the discounted cash flow, or DCF, method. As a data scientist, models you build may serve as inputs to cash flow models. For example, predicting growth or churn rates. Understanding how financial modeling works can help inform your own model building process. More broadly, financial value motivates stakeholders through your business to prioritize projects and invest the company's resources. Learning about quantifying and communicating financial impact may help you translate important data science metrics, like AUC, into dollar values more meaningful to business leaders. So what is a cash flow model? Broadly, it consists of three components: inputs and assumptions about our business, core financial calculations, and summary metrics. Let's examine each piece one at a time in the context of a new product launch. Business inputs include our assumptions on the core economics of our business. For example, we use these to calculate our revenues and expenses. Examples of business inputs are the sales volume, or number of units sold, and the sales price per unit, and the cost to produce each unit. Financial calculations help us translate our unique business models into a standardized set of metrics such as gross profits, operating profits, net income, and the all-important metric of cash flow. We will learn more about the definitions and the calculations of these metrics later in this chapter. Cash flow is our cash in hand that we expect to gain or lose at each time period due to our project that we are valuing. Once we have forecasted cash flow, it serves as the core input to calculating performance metrics and evaluating investment opportunities, as we will see in chapters 3 and 4. One last note. You may notice from our toy example that cash flow statements generally have a specific format, as shown in the top image. Time periods move left to right across the columns, and variables are arranged top to bottom in rows. This is the opposite of how data scientists tend to work with tabular or tidy data, as shown below, where columns are the variables and rows are the observations. In this course, we will see some examples with both data representations. And in the final chapter, we will also practice switching between them. Now it's your turn to try your hand at a